So Boyle's law is something we discussed, and I threw some stuff together here in my kitchen. This is a thing I bought. You can see it's at 40 milliliters, and there's a couple things that are going to drive me nuts here. One is that it's at zero, and what I'm going to do here is open it up to atmospheric pressure, and you can see it stays at zero. The other thing is that it's an HPA. So, one thing we know for sure, there's no such thing as a zero pressure, right? The pressure is one atmosphere or 101.3 kPa or 760 millimeters of mercury, 14. None of these are zero. We're going to focus on this one, the kPa one, because even though this isn't kPa, it's HPA. Thanks, science. Yet another thing. Uh, HPA is basically 10 hectopascals equal a kilopascal. So we're going to go with that. So we're going to use the kilopascal one. So for this lab, we're going to say we're starting at 101. Actually, yeah, I can show you that too. Why are we starting at 101? Because if you go to the National Weather at Raleigh Durham Airport, you can see that the pressure is measured in the sea level MB. I don't even want to look into that. But this is inches of mercury versus millimeters. And if you convert 30.10 inches into millimeters, you can see that's basically 760. So we're going to say we're at 101 kilopascals. I don't think we're going too nuts there. All right. So 101 kilopascals is 40. So actually, then on your data sheet, so you got a Boyle's Lab spreadsheet. What you will want to do is make a copy. It should have forced you to make a copy if I did it right. And what I want you to name it is your period first. So either a two, three, or a four, um, and then your last name. If you're one of my sets of people with the same last name, it would be nice if you threw in a first letter, but I'll be able to figure it out if you don't. So the number of your period, your last name, and that's it, and then say okay. And there it is. So now you'll have this at your disposal. The volume. So we're going to start with 40. This is in milliliters. I guess I should have put that. I will put that here in a second. First, we'll have milliliters. I just occurred to me. All right. So we're going to start at 40, and we're going to say 40 is a 101 kPa. Right. So our pressure then is in kPa. I just translated the zero into a 101. All right. Now, what I do in the video, going back to the video, now what I do in the video is I'm going to bring it down to 35, and you should see, so I squeeze this thing down, and you should see as I do that, the pressure is going up because I'm making less room for the gas to do this. Now you have to understand I'm an old man and I can't always see things. So there we are, and I'm going to read that as, so that's my 35, and I'm going to read that as, so each one of these is 50. So that's 50, that's 100, and it's a little over 100. So this would be 150. So I'm going to go and say that that is in between 100 and 150. So let's say 120. So escape that. Now we're translating this into kilopascals. So my 35 measure was 15 higher than that, if that makes sense. Wait, 120. What did I say? 120? That's 100. Yeah, so like 120. So 120 is 12, and 12 plus that is 113. So 113 is what that is. All right, so I said it's about 120 higher than zero. And so 120, and again, because there's 10 of these for whatever, that means I'm adding 12 to that. So it's 113. Okay, moving on. Now I'm going to press it again. So I will squeeze it down to 40. So now it's at 35, and we're going to squeeze it down. I'm sorry, to 30. So we're shooting for this line here, and you want the top of that, not the bottom of it. You want the top of the when you're doing a lab. The bottom of that is way down here, but where you measure is from the top of that syringe, not the bottom of the meniscus there. Okay, so now we're at 30, and so that's 100. Let's freeze it there. Oh, 1 second too fast. Let's freeze it there. Okay, so that's 100, 150, 200, 250. That's almost ballpark right on 300. So that's, or I'm sorry, yeah, 300. So 300 converted to kilopascals is 30. So 101 plus 30 is going to be 131. So 101 plus 30 is 131. So at the reading of 30 milliliters, I was at 131. Okay, so we were up 30 kilopascals higher than 101. All right, now we're going to go and do, let's do 25 milliliters. So I will now squeeze this thing to 25. So I will push this down. So now we're trying to get the top of the syringe to 25. And it's pushing all that pressure, right? So the pressure is all locked, and so the pressure is going up. So all the molecules are bouncing around more and more. There's less room here. So that's about 25. And now my reading is, so this is 500, and each one of these is 50. So that's 550. It's in between 550 and uh, 600, right? So it's in between 550 and 600. So let's go with 570, I guess, right? So 550, it's a little bit above 550 and not quite, and we can only guess one since we're doing significant digits because this is an actual lab. All right, so let's go. So 570 plus 101 is 1570. Oops, 157. There we go. 570. Yes. All right. And then the next one, what's the next one? Next one we'll do, and the last, well, not the last one. We'll do 20 milliliters, and then 20 milliliters is the next one I'll do. So we'll get that going, and you'll see I squish it down to 20. So this is getting harder and harder for me to squeeze this thing because the pressure is building up. And so as I get down to 20 milliliters, which I don't quite get to, honestly. Oh, no, I do. Almost. It's still a little low. But look at that. Dead on. We're going to call it 1,000. So 1,000 is 100. So if it's 100, right, it's 100 because it's hectopascals. So that's going to give us, we're just going to call that 200. All right. And then what I do is I go backwards to 50. So to show you how good a piece of instrumentation I got here, I actually scroll it all the way back to 40 to show you that it goes back to 0. So I am now releasing, right, giving the air more room to move around, and you can see I'm going down to 0. And when I get back to 40, look how well calibrated this thing is. I paid for something. It wasn't for the units for sure. Look, I'm right back at 0 when I'm at 40. So that holds pressure pretty good. And now I'm going to go backwards to 50 to show you that it's kind of a nice image here. So we're going, that's 50 milliliters. And now we're negative, right? So now we went into the negative region. Let me freeze it, freeze it. Okay. So now we're in the negative region. So it was less than 100. And if we're going to go backwards, so that's 100, that's 150, right? So it's 100, 150. That would be 200. So we're not quite at 200. We're somewhere ballpark about 18, I'd say, right? 180. So that's not quite at 200, and it's not at 150. So I'm going to call that 180, which is 18 from, oops. So let's do 18 from our original. So that gives us 82. All right. So here's our data that we got from that pressure thing. Now, a smarter man would have given you a whole view of the thermometer still being at 18.1 centimeters, but I did not. So let's undo that. what we talked about is volume times pressure equals a constant. So let's figure that out. So the way you use a spreadsheet, I've already entitled this column as volume times pressure. So we're going to make the spreadsheet know it's going to do some math by putting in an equal sign. So all I did was press the equals, and now it's going to say equals what? What do you want me to do? So I want it to take this thing. So I'm going to click uh, this cell is what they call it. And it's going to say, you want me to take A2? And that's what it is. It's A number two. And I was like, yes. And then I want it to multiply. So shift 8, the little star above your 8, means multiply. And I want to multiply this thing by this thing, which is B2. So I could write in B2 if I wanted to, or I could just click the thing. So it says, you want me to make this square equal A2 times B2? And I say yes. So I'm going to hit enter, and then it's going to do the math for me. Look at that. Now I want it to multiply this times that, and I want to multiply this times that. I want to do it all the way down. So the way you can tell the computer what you did here, I want you to do for these two, and I want you to do for these two. So for row 3, I want you to multiply these two things. If I take the cell here, get to the corner where that little box is, and I get this plus sign, I can then drag it down, and it'll do that for every one of these numbers. So 50 times 82 is 4100. 40 times 101 is 4040. 35 times 113 is 3955. 30 times 131 is 3930. So you can see here our constant thing is pretty good, especially when you consider we only have this to about two significant digits. If you round all these to two significant digits, you're between 39 and 40. I guess 41. Thanks, first one. Anyway, um, so this is what we're talking about equals a constant. So the volume times the pressure equals a constant. You're getting about the same number every time, which is good. All right. Now, if we were to graph these things, let's graph these things. So this times that equals a constant. So to graph these things, I'm going to select, oops, not even that. I'm going to select all two rows. So I just started here, held down my cursor, and dragged it all the way down here, and I got this. And I want to insert a chart. So we're going to make a graph, kids. And there it is. Our chart is now pressure versus volume. But if you remember when we did this, um, Boyle's law, here he is. We did volume on on the y and p on the. So let's try to do that. So let's tell this, instead of doing the x-axis, the volume, what I would like, well, a couple things I would like. First thing I would like is for this to move down. So I want to select it and move it down so I can see my data. Okay, now what I want to do is hit these three dots and say edit this chart. And I want my x-axis not to be volume. I want my x-axis to be pressure. And then it's, well, what about your y-axis? It calls it a series. And I want my y-axis to be volume, and then close. And then look how lovely this is. It took care of it. Now these are my volume readings, the 50, the 40, the 35, the 30, and these are my pressure readings. The problem is, because it's a computer and it hasn't taken over our lives yet, we have to correct it. It thinks these are still the volume in milliliters. So if you double click that and say, no, silly, that's not volume in milliliters, that's pressure in kPa now. So I did that by just clicking on the words, and then I could literally just change them there. So then this is no longer pressure, it's volume. So I'm going to double click that and say this is now volume in milliliters, because I switched the axes. So there you have it. Now these are volume in milliliters, that's what they were. And this is pressure in kPa. And look at that graph, kids. It looks strikingly, I say, like this. In fact, if we want to insert a trend line, as you can hear from behind me, my ride is here. If we want to see a trend line, we can hit series and trend line. Okay, so how did I get here? There's a whole list of things here. We were down. Actually, how did I get there? Okay, let's we can edit chart. That's how we get it. And then we want to check series, customize. There we go. So series, and then I want to put a trend line in here. So the trend line is here. It tries to put a straight line. I go, no, I don't want a straight line. I want more of like this kind of line. See, now it's all curvy like the one I want. So polynomial, exponential, not quite as good. So let's go with polynomial. There we go. Uh, a nice curve that looks more like what we told you it would look like. Okay, so now my contention to you was that pressure versus 1 over liters would be, I told you this would be a straight line. And the reason this would be a straight line, why am I out of practice? The reason this would be a straight line is because if PV equals a constant, right? If P times V equals a constant, then if I divide both sides by V, I get pressure. Oops, nope, divide. Yeah, I did. Pressure equals a constant times 1 over V, right? So if I take 1 over V, I will then have a graph like that, where pressure is on the Y and 1 over V is on the X. Okay, so that's what I'm going to do now. And like I said, basically you're just learning how to use this thing. Okay, so now I want to take all my volumes and turn them into 1 over V. So I'm going to put the equal sign because I need the thing to do math again. So I'm going to say equals, okay? And then I want 1 divided by whatever's in this box. So the way I did that is I hit equals. I'm doing math. I'm telling the spreadsheet, do math in this box. I want 1 divided by whatever the volume is. So 1 divided by, and the volume is in A2. So I want to click that box and it says in A2. I go yes, and I hit enter. And so that is 1 over 50. And now I want it to do that 1 over for all these. So again, I go to this cell, I go to the end corner where there's that little block till I get a little cross, and then I drag it down, and there it is. It now did that math for every one of these volumes. Okay, so now I want to make a new chart. I want to make a new chart with this and that. This gets a little tricky. So um, I am going to, probably the easiest way to do this is to just copy this. So I'm going to copy chart. All right, so the 3 little buttons here. How did I get the 3 little buttons? I clicked on the chart and I got the 3 little buttons and I said, I want to copy this chart. Now, the beauty of Google is it's going to put this copy right smack dab on top of the old one. So I have to move it to reveal. Oh, no, it's not. Never mind. I am going to paste it here. So you can either hit edit paste or you can control V, however you want. So there, now I got the exact same chart I had there. But I want to edit this chart so that it doesn't use pressure versus volume, it uses pressure versus 1 over volume. So I want to edit the chart, and I want my series, which is my my y-axis. So I want my y-axis, if we want it to look like this, I want my y-axis now to be pressure. So I want my y-axis to be pressure. Okay, and I want my x-axis to be 1 over v. Now 1 over v isn't one of the options. Mr. Roach, what the heck? So you need to say, all right, I want my x-axis to be 1 over v. So I'm going to click on this thing. Nope. I'm going to click on this thing, which says add selected data range. And it says, what data range? And so I got to go back to my little chart and say this data range and select the 1 over v. Oops, went too far. I say this data range. Okay, so what I did was I clicked my mouse at the 1 over V and I dragged it all the way down to the 0.5. I'm going to hit enter. So now my x-axis is 1 over V and my pressure is is the pressure, is the y-axis. Just like this. Pressure is the y-axis and 1 over V is my x-axis. So in theory, if we pull back and take a look at what we did, we're going to say, oh, ladies and gentlemen, a straight line. Would you look at that? Now, we do have to mix this up because it says it's volume. That's not volume. So we're going to double click that and say, silly computer, that's now pressure in kPa. That, and then we're going to go down to our other axis and say, silly computer, that's now volume. Oops, 1 over volume. 1 over volume. Volume. Enter. There. There it is. Ta-da! Pressure. So the titles aren't right, but just for people who care. Pressure versus 1 over volume is a straight line, and volume versus pressure is something of that curvy line like we told you it would be right here. And that is your lab.